Right, here we're going to look at another example of these specific heat calculations. Here's our problem. A gold ring is heated by a lit match. So you can imagine my wedding band here is actually a gold ring. Assume for our purposes here that it's solid, pure gold. I wish. So we have a gold ring heated by a lit match. The match releases 1,000 joules of heat, which is true. Most matches, when struck, release 1,000 joules. And the specific heat of gold is 0.126 joules per gram degree Celsius. Notice how much smaller that is than water. How much will the temperature of the 40-gram ring increase? So basically, if I took my ring and I lit a match under it, how much would the temperature of this ring increase by? So that's our problem. That's what we're trying to figure out. And in order to do this, it's problem solving. You guys know what that looks like. So we write down our givens. What all stuff do they tell us? So we go through the problem. We find they give us 1,000 joules of heat. So that's heat. And they tell us the specific heat of gold. And that's joules per gram degree Celsius. And this is the specific heat of gold. And that matters because the specific heat of each substance is different. So if I was dealing with something where I had two different substances that were heating up, I would have to keep track of which specific heat belongs to which. And we have 40 grams. Remember, grams is a unit of mass. So that's all for our givens. I don't see anything else in there. Now, what are we trying to find in this problem? How much will the temperature of the ring increase? So we are looking for a change in temperature, delta T. Now, just as before, we use our equation. Heat, remember Q is heat, is equal to mass times the specific heat times the change in temperature. And now it becomes really important to remember that this delta T, the change in temperature, that's treated like it's all one letter. So this is all one symbol right there, not multiple symbols. And now, just as before, we're going to substitute what we know from our givens into our equation. So first, 1,000 joules, that's a heat kind of quantity. And so we need to put that in for heat, which is Q. So instead of Q, let's write 1,000. And remember, don't need units. Our mass is 40. Our specific heat is 0.126. And we don't know our change in temperature. That's what we're trying to find. So now I need to solve this problem. So let's simplify first. I can do 40 times 0.126. Yay for trusty calculators. 0.126, and we find that that is 5.04. So notice that I'm not going to rush ahead and try and do this all in one step and then just present my answer. I'm going to do this a piece at a time. So again, I multiplied 40 times 0.126, and I got 5.04. So I'm going to rewrite this equation now as 1,000 equals 5.04 times a change in temperature. Now I want to find just that change in temperature by itself, but I'm multiplying it by 5.04 and I don't want that, so now I have to divide both sides by 5.04. And when I do that, these two will cancel out, and I will end up with, you can hear my furious typing, I'm sure. 198.4 will be my change in temperature. So I guess you can imagine I would not want to grab that ring after that. It would be extremely warm. And I'm going to rewrite this now. Most people are more comfortable with the variable over here on the left side. So I'm just going to rewrite this, and I'm going to include units. This is temperature in degrees Celsius. We know that because it was given in degrees Celsius up here. And so my change in temperature would be 198.4 degrees Celsius. So moral of the story is, if you put a small metal object and that object is made of gold under a match, don't grab it. It's going to be warm for just a brief second or two. All right, that's all she wrote.